So hello class and welcome to this lesson. You remember guys, last time we talked about methods. So we are able to structure our program into subprograms, and these subprograms are methods called methods. And we can take advantage of this technique or the structure by writing the program once and call it multiple times whenever you want it, whenever you need it. So that was the subject last week, and we'll be using it this week and in the coming weeks as well. Today, we'll talk about the arrays. And here in this lecture, we'll talk about one-dimensional array. Next week, we'll talk about two-dimensional arrays or multiple or multi-dimensional arrays. So in the past, if we want to save some data, we can declare a simple primitive data type, and that variable of type, let's say integer, can save one element at a time, correct? But if we say that we have, let me bring the pen here. Let's say we have integer a, okay, and we say that the a equals to 7. It's a horrible writing. And then we say a equals to 8. Now the variable a has an updated value, which is 8, and we have no more access to the 7, and the 7 is overridden. It's deleted. It's not there anymore. So what if we want to keep tracking of all of the values? We want to save all the values and get back to them whenever we need them while our program is running. So that's why we need to know about a one-dimensional array, or an array that is a data structure that can save multiple elements at the same time. So here is a problem, as I will share it with you. Read 100 numbers. So we want to read 100 numbers, compute their average, and then to find how many numbers are above the average. So we need to keep track of all of these 100 numbers, finding the summation, finding the average, and then going back to check each element of these numbers, or each number, is it above or not, above the average or not. So that's why we need to store all of these 100 numbers and get back to them to compare them to the average. This is a long process. If we just use regular variables, we have to use 100 variables, right, to save all of these numbers. And this is not a practical way to work with this number of elements. So instead, we can use an array that can save all of these numbers, and we can set the size for this array and reserve a memory space that can hold all of these 100 numbers, and we can access them whenever we want them. We can go back and forth. We can do a lot of processes on those numbers without losing any one of them while the program is running. So this is a good example to use an array, and especially the one we are talking about, the one-dimensional array, okay, to store the 100 numbers. So we'll talk about many objectives here in this week, and we'll talk about what is an array, or why we need the array, how to declare array, how to send an array to a method, how to pass it to a method, how to retrieve an array from a method, and much more. We'll learn a lot this week, okay? So here is a diagram showing you a one-dimensional array. So here is the array, okay? It's like memory slots and we can save some data in each slot. So here, this array must have a name, and the name is here in this example is my list. So this array has a name, and the name we can set it as we want, following the same rules of any variable. So, and this name called the reference to the array. Okay, and the array has multiple elements. We can specify how many elements do we need or we want to have in this array. We can say that this array has 10 elements. We can do more or less, depend on the application, depends on the problem or the scenario. So in this example, we have an array of size 10 to save 10 elements of type double. Okay, so all of these are numbers that are saved in this array. And this array has, as we mentioned, multiple cells. Each cell has a number, an index. You see here, index 0, 1, 2, 3, 4, and so on until the last element, which is the size -1, which here is 9, right? To access any of these elements, we need to use the name of the array or the reference name, and then the square brackets. You cannot change that. You cannot use parentheses. You cannot use curly braces. You have to use the square brackets, and then which index you want to access. So the index is starting from 0. 0 is the index of the first element in the array. Number 1, index 1 is referring to the second. Number 2 is referring to the third, and so on. You see that? The last element is the size -1. 9 is referring to the last element in this array. So now we are saving all of these elements. Maybe these are related elements, like saving the scores for my students for this class. So all of these are related data related to the student, to the class, and to the professor, maybe. Okay, so these will be saved in one place. This is the array. This is the data structure that can hold multiple elements. And this is the new thing here, which is different than the variables that we were working with in the past. Okay, the regular variables just holding one element at a time. And now let's come to how to access this number. Okay, 45.45. To access it, we have to start with the name of the array, then the index, and that will help the compiler to identify which element of this array you want to access or modify or update or read, write, whatever you want to do. Okay, now this is the array. This is the design of the array that can be in the memory. And the array here is a one-dimensional array, has one column. Whether it's one column or one row, it's considered as a one-dimensional array. Now, how to declare an array? This is an example of declaring the array that we just displayed on the screen here. And we will have the name. We can pick any name, starting with a letter, followed by a sequence of letters and or digits. We can use the underscore. And then what is the data type? The point here, you need to know that all the elements of the array, of any array, must be of the same data type. So here, this array is of type double. So all the elements are of type double. Even this one will be considered as double, okay? So all of them are of type double. We cannot mix the data. We cannot have an array with integers, floats, doubles, characters, strings. We cannot have that. The array has one data type at a time. Okay, when you declare it, you'll say this array will be created of type X, let's say double or integer or strings or characters, whatever you want. Okay, then the square brackets telling the compiler we are about to declare an array of type double. The name is my list, and here we are actually creating. New is a keyword. This is a keyword telling the compiler, let's start creating this array of type double, and here is the size. This is the size of the array that we want to create. So size is 10. The index starts from 0 to 10 minus 1, which is 9. Any questions?
No.
Okay. So the array is a data structure that represents a collection of the same types of data. So collection that can hold many elements, but all these elements are of the same data type. And here is an example of declaring an array. Okay. So you need to put in your mind, we have a reference name and we have an index. To access any element, we need to use both of these parts, the reference name and the index, to access any of these elements. Okay. There are different ways to declare an array. So we can do all in one line or in two separate lines. We can use the declare the array reference and the data type in one line, like this example, or we can do it all together, as I will show you here shortly. So let's switch to NetBeans and let's start our first example to demonstrate this topic. And here so this is a new project, and if I want to create an array to store the scores, so I will say, I will assume that all the scores are integers. So I will say integer, and then this is an array, and the name scores, and this is the reference name equals to new. This is the keyword that I want to use. And then what is the type and the size? So I will say we have 5 students or 5 scores. I want to save them in this array. So I'm creating an empty array, one-dimensional array of type integer of size 5. This is an empty, and by default, the integer, the array of type integer will be filled with just zeros. The default value is 0. So I can now start filling the array and assigning some numbers. So if I want to access any element of this array, we have to use the scores, then the reference name, and then the square brackets followed by the index. Okay, so here is the index. I will start with the first index and we'll say, let's say 80. This is the first score. I am saving it in this array. I can go ahead and move to the next student, which is index 1 equals to 76, let's say, and so on. We can fill the array one by one. We can do this with small array, but if we have bigger arrays, then this is not a practical way to keep writing the same statement again and again. I can use for loop to help me to repeat the process. But for now, let's keep it simple and short here. It's not short, simple and easy. And here I am filling the array with some elements. I can keep doing this, which I don't prefer to do, but just to show you some examples. And here is 4. So we have from 0 to 4, the size -1. We have all the elements set with some scores. And now I can print any of these. Let's try printing the first one and to see if it is stored or not. Is that correct or not? And here we go. Print the array name and the index. So I want the first score, just only 1. And here, if I run it, I can see the result is 80, which is the first element that I have. I can access any one randomly. I can go to number 3 right away, okay? And I can see that we have 90 in index 3. You see that? I can go ahead and print all of them, 0, 1, 2, and so on. And we can have all of these numbers, as you can see. So these numbers are stored in the array. It's in the memory. We have the reference name. We know the index referring to a specific element in this array. And we can save data and retrieve the data, or even we can modify the data. I can say let scores of 0 plus equals to 5. Let's say we'll give the student 5 extra credits. So I can do this for all of the elements, okay? So we'll keep and repeat this again and again to fill all of the elements. So 3, 4. So here we can see some samples. We have already updated the array, started with 80 and incrementing or adding 5 points. So we have 85, the second one, 81, and 93. Okay. Any questions, guys? Is it clear?
Yeah.
Excellent. Okay, but you know, here we are repeating the same step here, scores and scores here. And you see here the index going from 0 to size -1, 4, right? 5 minus 1, which is 4. So I can replace those numbers by a variable, and this variable can be represented by a 4 counter, and the 4 will go from 0 to 4, right? And this will help me to traverse the array to go from one index to the other. So we can do this. Now, let me delete these steps. Okay, and we'll do another way. So here I will fill the array with random numbers. Okay, and here the numbers will be, let's say, from 1 to 100. Okay, so and then converting this into, or casting this into an integer and save it in the array. I don't want to repeat this step again and again for index 0, 1, 2, 3, 4. Instead, I will do a better job. I will use a 4 counter, which is I, representing the index from 0 to the array size, which is 5 here. Moving this inside the 4 counter. And here, instead of 0, index of 0, I should do what? Can you tell me, guys? To repeat this for all the elements of the array, not just index 0.
I.
Excellent. I. See that? I. So I will be first 0, right? And then I will be incremented by 1, will be 1, 2, 3, 4, and we'll stop there. Okay. So let me comment these lines. And here, just to print some samples, we'll do 4 counters for counter for these as well. But for now, let's keep it as is. We just modify the first half of this program. Now, if we run it, we have some random numbers between 1 and 100, okay? And we printed just 3 of them. If you want to print all of them, you can keep printing the rest. Scores of 3 and scores of 4, okay? Now, let's do this using a 4 counter again. So instead of repeating the print line 5 times to print all the elements of the array, I'll use the 4 again, index from 0 to 5. And here we'll say just print all the elements. That's it, the same. So here we have at the top, we are reading and filling the array with random numbers between 1 and 100. And then here again, we are showing and displaying the array from 0 to 4, the index 0 to 4. So here we go. We have the numbers. These are the numbers that are generated and saved in the array, right? So here, remember, we have the I, which is representing the index. So we are using the 4 to help us to generate the index. Instead of repeating this statement 5 times, we can use the 4 counter to do the job for us, to shorten the code and let the computer do something to give the results that we want. Okay, so another thing. So here we specified the size is less than 5, which is 4, stopping at 4. Instead of hard coding and writing a constant here, we can do another way. I can use a method named length to find out what is the size of this array. So scores.length. This will help me to check and bring or return back what is the size. So instead of hard coding the number, I can do this. The reference name, the array reference name dot, there is a method named length, which is returning the size of the array. You can test it here. We can print the size of the array is length. So let's see this here. And here we go. You see that? It's telling you it's 5. So you can use this method to help you to walk through the array to know where to stop. And this is the length, okay? You can do the same thing here. Instead of 5, you can repeat the same thing, scores.length. Any questions? Is that clear, guys?
Yeah.
Yeah, I'm good.
Good, good, thanks. Now, I prefer all the time to have 3 segments when you work with arrays. The first segment of your code is to read the array. When I say that, when I say read, I mean to fill the array. Okay, to fill the array. So this is the first piece. The second piece is processing the array, another block. And the last block is printing or showing the results, showing the array. Okay, so this is my preference, and you can use this or any other ideas. So here I will do the process here. I want to increment all the elements by 5. Okay, so here say I, and here we go. So we have 3 parts. It's a program. The first part is to read the array or fill the array. Here to process the array. And here the last part is to print array. Good. Now we can have this doing the job here by incrementing the scores by 5, and we can print the result here. So all the scores are incremented and getting the results. So how about printing the array before the increment and after the increment? So we need to do this block twice, correct? Look at this. So I will copy this block, okay, and we'll paste it here. So I read the array, print the array, process the array, and print it again. So I can see the array printed twice, okay? So one before and one after. I can do some empty spaces like here, some dashes here, and this is the array before and after. Okay, 54, now it's 59 after the increments. Okay, so here we repeated this code twice. You see here, this is the first one, and here is the second one. The same code repeated twice. Question, guys, can we do better here? Can we redesign the program in other ways? What do you think? Is this perfect, or we can do a better job? What we can change? There is something that we can improve here in terms of the structure of this program. Okay, what we learned last week?
Methods.
Good. Why we need methods? Who can answer? I just mentioned the beginning of the class, and it's what
It's
we
to simplify stuff and to help make like reusable code.
excellent. Yes. So simplify instead of repeating the code here, right? Repeat it here and here. Why we are doing so? Let's move this block of code into a method and name this method as print. And whenever we want to print the method, we don't need to write the code again. we need just to call that method. Right, guys?
Right.
Excellent.
Right.
So let's do this. So here I will go with this code. I'll cut this code and we'll delete this code here. Okay, so we have no printing. Okay, we didn't print the array yet. Let's create a method. So here, public static void, name it as print. This method is to print. Here, print. Now, what we want to print? We want to print the array or any array that we are sending from the main. So that's why I will say this array, this method has one parameter, which is an array and named scores. This is how to set the parameter if we want to work with arrays. Okay. And now let's paste this code, the same code. Let's paste it, the same one. I'll move this line to the end. Okay. And here we go. That's it. We have a method now. We designed a method, a user-defined method. We named it as print. You can name it whatever you want. And then we have one parameter, this parameter named scores, and it is an array type integer. Good. And here is the same
Could
code.
you copy and paste that whole thing into the chat for me?
You want the full program?
Yes, please, if you could.
Yes.
Thank you.
You want. Received?
Yes, thank you.
You want. Okay. So we have this method that will do the job to print the array. Whenever we want to print the array, there is no need to write this code again. All what we need to do is call this name, this method, print. Okay, so let's do it. Now here, reading the array, now we want to print it here. So to call it, what's the name? Print. This is the method that we just declared. And now pass the array. What's the name of the array? You need to pass the reference name. The reference name is scores, no brackets, no index. You want to send the reference. You want to send the reference. This is how to do this. So one line will do the job for us, one line. And now if you want to call it again after the update, do it again, one line. You see here? So this is a more structured program, and we have some code that we needed again and again. So why not to write it somewhere, label it, and call it whenever we want. So we have it here in this method. We labeled it as print, and we are calling it here. Are we done? Did you copy this, guys? You want more time? Okay.
Yeah, just give me a little,
Yeah.
one more minute.
Okay.
Thank you.
Okay, you're welcome. Okay, so now we have the method, the array declared here. We fill the array with random numbers, and here we printed the array, update the array, and print it again. Okay. Let's do another method to find the summation for all these elements. So we'll do public static. And now we want something and to be returned sum. And here we are saying integer scores, the same thing here. And we'll do the summation. We will receive the array and we'll find the total and return it back to the main. I'll give you a couple of minutes to think about this and start scratching and doing some code here. Then we'll solve it together. Okay, I'll give you 5 minutes. To your answer. So here first I will create a local variable initialized to 0, and then we'll traverse the array, walk through all the elements. And now all what you do, that's it, as simple as that. Okay, simple, straightforward. Just this is the 4, the same one we did before, and here just add them up. At the end, you need to return the results. Okay, that's it. This is the method returning the result that is saved here. Do you hear me well, guys? Hello?
We can hear you.
Yeah, okay. Yeah, I saw.
Yeah, we can hear you.
Yeah, okay. Good. And this is what we want to return. Now let's go to the main method here. And let's call this method the sum. So here we will say print the summation by calling the method sum and send the array name scores. Run, and here is it. We can say total is, this is the result. Okay, we have the size, we have the initial array, we have the updated one, and we have the summation here. Okay, so this is the code here to find the summation. Any questions? If not, let's do one more last example before we move to the lab of this week. So we have a method named print, a method to find the summation, and now we can have a method to find the maximum number in the array. We'll do almost the same, but saving the max and return it back to the caller, which is the main. Public static integer max, and here the array. By the way, you can name it scores or any other names. Okay, you can name it whatever name you want here. It doesn't have to be matching the name in the main. Okay. So we are about to find the maximum number. So we'll declare a variable let's say, and let's assume that the first element is the maximum one. And here for I, we can start from 0, but I will start from 1 because we already saved the first one and we assumed it as the max. And here is the scores length. Now let's start comparing. If the scores of I is bigger than the max, the current M, which is the first element, then just do the update. Update the max with scores of I. Just do the update. Okay, so this will not be updated unless we have satisfied this condition. If we have a new number is bigger than the one we already saved. Okay, and then at the end here, just return the maximum number. So this is the method max that is accepting one parameter, which is an array, and returning one value. And here initializing the variable M with the first element in the array, assuming this is the maximum number. If there is something bigger, we will replace it as we do here, as we did here. Otherwise, the M will be the same with no changes. At the end of this method, we are returning the M to the caller. Okay. Give you a minute to copy this. Okay, so now let's use this method that we just created, and let's go to the main here, up to the main, and let's print what is the maximum number here. Max is here, the name is max, the array that we want to check is scores, and let's see. This is the maximum number, 88. You see here, we can find which one is the max. Okay, calling the method, passing the array. You need to pay attention how to pass the array and how to receive the array in the method. Okay, so just work with the reference, send the reference, and here how to declare the array as a parameter in the array. Pay attention to this, write it down. Just if I send you the code, copy and paste, this will not help you. You need to do it by yourself, okay? You need to practice, you need to write letter by letter. So this is the method accepting one parameter of type scores, which is an array of type integer, okay? So last question here, what should I do to find the minimum number? How can I modify this method to find the minimum number?
Well, wouldn't you just swap the greater than symbol?
Yes, good job. That's all. You see, as simple as this. Okay,
Okay.
that's it. So you can create another method. You can copy all of this code and name it as min, and then switch the sign, and then you have another method to find the minimum number. So you have max, min, and so on. Good job. Okay, so now it's time to practice and to switch to the lab. Okay.